today we'll be talking about ordering real numbers. Okay, so a real number is any number I can put on a number line. That is basically what a real number is. And so that includes all of the rational numbers we talked about, which means any number that can be made into a fraction that terminates or repeats. And then it includes all of the irrational numbers we talked about, which includes all of the numbers that do not repeat and or do not terminate. Those are irrational numbers. So ordering real numbers is we put these numbers in order, whether it be rational or irrational or both. So the first bit of information, and again, you can pause this and then write it down and then restart it. But when ordering real numbers, numbers are placed in ascending or descending order. Numbers can also be placed on the number line. So a lot of times you'll see maybe they give it to you on a table, they give you a list of numbers and ask you to put them in order, or they might give you a number line and say, hey, put these numbers in order. Either way, it's the same process. And so ascending means the numbers are starting from the bottom and going up, which in mathematical terms means we're going from least to greatest. We're going from least to greatest. And then we have descending, means you're starting at the top and coming down. We have that is greatest to least. So descending is greatest to least. So here's an example. We have negative 11 over 6, 23 hundredths, 6 fifths, the square root of 17, and then the square root of 19. And so if you notice, we have a few rational numbers like 6 fifths and 23 hundredths, negative 11 over 6. Those are rational numbers, but then we have some irrational numbers as well. We have the square root of 17 and the square root of 19. Those are irrational. And so you could pause it here to write these numbers and write the number line. That's okay. But either way, our job is to put these numbers onto that number line. Okay. So the first thing you need to do, the first step to solving this is to convert all numbers to decimals. So you want to convert all these numbers to decimals. Obviously, 23 hundredths is already a decimal, but then you would take negative 11 over 6 and divide that. You divide 11 by 6, and whatever decimal you get, you make it negative. That would be negative 11 over 6. We have 23 hundredths is already a decimal. 6 fifths, you would take 6 and divide by 5, because again, every fraction is a division problem. This is the top divided by the bottom, or the numerator divided by the denominator. So it would be 6 divided by 5. And then we have the square root of 17. Now, if you're not using a calculator, you won't be perfect, but you can either kind of estimate. You can give a general estimation. You can say, hey, the square root of 17 is really close to the square root of 16, so that number is probably right about here. Or you can use the strategies I showed you in the last video to figure out a more appropriate approximation of what the square root of 17 is. The same thing with the square root of 19. So we could do the process I showed you in the last video, or you can do a general estimation. Either way, you'll probably be about correct. So convert all those numbers to decimals. Once you do so, you could then place those numbers onto the number line. So for instance, 23 hundredths is barely past 0. Okay, so 23 hundredths would be about here. 1, 2, 3. It's before 1. That number is clearly smaller than 1. It would be like having 23 cents, and this would be $1. So it's clearly less than $1, but it's a little bit more than having no money at all if you had 23 cents. And so I kind of like to think of it that way. I like to think of things in terms of money, right? And so if I was to divide 6 fifths, I'm going to get 1.2. And you guys make sure. And so really, let me do it like this. Really, when you divide these numbers, you should put the decimal underneath. So you divide 6 divided by 5, underneath it we get 1.2. And that goes with this one. And so if you get the square root of 17, you're going to get about 4.1. And then the square root of 19, you would get about 4.3. So you put that underneath there. And then if you take negative 11 over 6, you're going to get negative 1.83 repeating. So it's rational because it repeats. So you would get that, right? And so now I can take these decimals and I can put them on the number line. And so just by default, I'm putting these numbers in order from least to greatest, because least would be over here and greatest would be over here, right? So when I place them on there, I can say that 6/5 is 1.2, so that's going to be about here. So right here would be 6/5. Okay, and I know that because I made it a decimal, and I know that 1.2 is barely past 1, and so I will put it about there, right? And then so I look at the square root of 17 is 4.1, so I will put that about here. Square root of 17, about there. The square root of 19 is 4.3, so that's a little bit past 4.1, about here. Square root of 19. Alright? And I know, let me zoom in a little bit. That doesn't even look like a 19, but that is 19. Okay, square root of 19, square root of 17. 6/5, 23 hundredths, and then of course we have the negative 1.83, which is in between the negative 1 and the negative 2, kind of closer to the 2, the negative 2. So I would say negative 11 over 6 would go there. And so I put them on the number line. Zoom out. Put them on a number line based on their decimals. So make sure you convert these numbers to decimals before you order them on the number line. Okay. In class, we'll put them on number lines, and we will just order them from least to greatest, given a situation, right? So as long as you know that ascending means you're going from least to greatest, descending means you're going from greatest to least, and you're able to look at these numbers and convert them all to decimals. Okay, and the way you convert a fraction is you divide the numerator by the denominator, right? If it's a decimal, you don't have to worry about it. Again, here, numerator by the denominator. If I have an irrational square, then I'm going to use the process we used in the last video, or give a general estimation. Usually the general estimation will be enough, but if not, if you need to be more specific, you can. And then the same thing here, the square root of 19. So either way, you need decimals for all of them, and it's much easier to place on the number line.